The last section of our stats note, measuring correlation, the Pearson product moment correlation coefficient. And what would be a good acronym for all of those letters? The R value. I have no idea why we call it R for Pearson product moment correlation coefficient, but that is what it is. So what we're going to have to do is we're going to have to turn our diagnostics on our calculator, and the R value tells you how close the points are. So we have our line of best fit, which makes the best line possible, and then we get an R value, and the closer that R value is to 1, the better it is for predicting the data points, or the closer it is to a perfect line. So R values are between -1 and 1. 0 represents no correlation. The closer it is to 1, you have a stronger positive correlation, and the closer it is to -1 means that you have a stronger negative correlation. So here are some examples you can look at. That first example, very close points, has an R value of -0.9. Okay? Second one, a little bit more spread out. Last one, no correlation. They don't know whether the line of best fit should be positive, negative, or nothing. Here we have a strong positive correlation. Here they're all perfectly in a line, so your R value would be 1. So in our descriptors, if you get an R value between these values, this is how you could describe them. Right? Between 0.75 and 1, we could call that a strong correlation. Between 0.5 and 0.75, that's moderate. Anything less than 0.5 will be weak, and anything less than a quarter is very weak and almost can be considered that it has no correlation. So we're going to look a little bit about the mathematics that are used to figure this out, and then we're going to be thankful that our calculator does it in one step just by pushing enter. Again, so your correlation coefficient is Sxy over Sx over Sy. And what do those things mean? Well, we saw the Sxy in our previous formula, and it was this complicated sum formula. Sx is a square root of a bunch of complicated stuff. All of that put together gives us our correlation coefficient. So the points that we did before to find our line of best fit that we used the long formula with, 1, 3, 2, 1, and 3, 5, this part in your notes, and it's done for you, just shows the calculations all the way through. Okay? What you can do is you can plug in these 3 points into your calculator. Oh, you can do this later, and you can turn your diagnostic on and see if you get the same value. So, take out your calculator. You're going to have to go to catalog. And when you go to catalog, so I'm going to go second catalog, this is a list of all the commands on your calculator. So if you're ever lost and like, oh, I don't know where to find 1var stats, it'll be listed in here. Every single command is listed in here. You can go quickly to D by just pushing D, and then it goes to those ones, and then you'll have to scroll down until you find diagnostic. Turn diagnostic on, push enter, and just leave it on. Now every time you find a line of best fit, it will give you the correlation coefficient R and R squared. So I'd like you to put these values into your calculator. Did you get results like this? So there's my line of best fit. R value came out to 0.97, which is really close to 1. So that is a strong positive correlation. And then you could enter a value and get a mark of 53.7 as an estimate. You have 53.8?